Hi, welcome back. So let's see how we can apply this CNN on text processing. And the task that we want to do is sentiment analysis. If you remember in the very first lecture, I showed you an example for sentiment analysis. Essentially, you want to find out for a given piece of text what the sentiment is. Is it positive or negative? And possibly give a few more details about the sentiment. So a typical application would be in analyzing product reviews that you see online. I mentioned that this is a major commercial application of this kind of system. Companies can't go through all the reviews that are posted online on websites like Amazon, but they have to keep track of what people say about their products or services. Instead of a human going through all of them, basically you have systems scanning them and deciding, was this something positive or negative that was being said? And then this can be aggregated and shown in a dashboard to a human that looks at the feedback and possibly posts a response. So sentiment analysis is a major NLP task. And I showed you in the first lecture that there are cloud services, for example, the Amazon NLP services that you can run on the cloud. They have a service for sentiment analysis, but here we're going to try to build this ourselves. So again, we need training data, and the data that we're going to use is a data set with movie reviews from IMDb. So there's one publicly available data set from Stanford. It has 50,000 reviews that were pulled from IMDb, and there are up to 30 different reviews per movie. The dataset has been constructed in a way that it has an even number of positive and negative reviews. So if you just build a classifier that does random guessing, then you get 50% accuracy on average. Each review has a score from 0 to 10 or 1 to 10. I'm not sure. I think it's 1 to 10. I don't think you can give 0 stars. So a negative review is a score of smaller or equal to 4, and a positive review is a score with equal or bigger than 7. And in this data set, there are no neutral reviews. So it's either positive or negative. So as a positive example, if you download the data set here, you can find movie review number 6587 has a rating of 9 stars. So that's the naming scheme for the files. And it's for this movie here, and a generally positive review. The Master Blackmailer based off Sir Arthur Conan Doyle's short story, The Adventure of Charles Augustus Middleton, as the first feature-length Sherlock Holmes movie story with Jamie Brett that I've seen. And yeah, it goes on a bit, so you can read the whole review in the dataset. Similarly, as a negative example, movie review number 9985, only 1 star. Have I ever seen a film more shockingly inept? I can think of plenty that equal this one, but none which manage to outdo it. The cast are all horrible stereotypes, numbered with flat dialogue. I am ashamed for all the people involved, and so on and so on. So yeah, the full internet giving its verdict on the movie here. So we can train our classifier on these 50,000 reviews, and we have the value that we want to achieve. Now this is the score. So what we're going to do now is to build a CNN for classifying these movie reviews. And again, we're using a convolutional neural network, but the difference to the one before is that we have one-dimensional convolutions. So you see here, everywhere we had 2D layers, we now have one-dimensional layers. And the size of the layer corresponds to the number of embeddings that we have in the word vectors. Remember last time I showed you how you can get these from Spacie. So you have these predefined embeddings if you load a larger model, and then depending on the size of of the embeddings on the number of dimensions in the embeddings, we can define the shape of the network here. So we have a conv 1D filter, a max pooling layer, and then a dropout layer like before, 20% dropout, ReLU activation function. And then finally, the output for this layer is just a single neuron, where we use again sigmoid. So it's one neuron, which gives us a value between 0 to 1 after sigmoid activation. So now you can train this like before. And once you have trained the model, you can apply it on, well, of course, on movie reviews, but you can give it any other kind of text. And you can see what the sentiment for the text is. So here, even though it's trained on movie reviews, you could try to apply it on product reviews as well, or in general on input that you get, for example, in the chatbot. Now, chatbots are getting more and more sophisticated. One analysis they do is about the sentiment, about the human chatting with them. Imagine a bot that's used for customer service. They want to know, is the customer annoyed, angry, happy? And depending on the sentiment, they can change their answers a little bit, or maybe even forward the human to a real customer service representative, a real human that can take care of a very angry customer. So sentiment analysis is being used not just in product analysis, but also has applications in chatbots. So here, if we apply this onto the model, like before, you say predict. I'm skipping some code here, but you can see this in the book that I'll talk about in a minute. You get a prediction. In this case, it will predict a score of 0.1. So it's like 1 star. So you can see this is a very negative sentiment that's coming in here. Okay, so today you learned about deep learning. You learned one specific architecture, convolutional neural networks, and you've seen how to apply it for images and for text. You should read 2 chapters. The first one I took from this book here, the Generative Deep Learning. This is a fun book for experimenting with deep learning. It has a couple of networks that work with text, with images, and so on. And the example I took, I showed you with the image classification, you can find in chapter 2 in the book here. And then for text processing, it's the same book that we used before for natural language processing. Chapter 7, you can read about using CNNs for text processing, including the sentiment analysis example that I just showed you. And as always, we'll practice some of this in the lab. And I'll see you one more time for the last lecture in this course. See you then.